Maybe okay? Okay, so that finishes up the degree of unsaturation. We have your outlines. We've covered numbers 1 and 2 under chapter 3. Okay, so now we need to get into naming alkanes. Okay, you'll see this is a very easy thing to do. A little tricky to start with, and it's a very systematic way of naming these things. Okay, so the first thing in naming is to get these straight chains down. These are things you just have to memorize. So what we're going to do is just look at a series of alkanes. Okay, where we start with 1 carbon and then continue up to higher carbon counts. Okay, so CH4 for 1 carbon, that's called methane. 2 carbons, ethane. 3 carbons, propane. 4 carbons, butane, and so on. Okay, some of you may already have seen this kind of stuff before. Okay, so you want to know all the names from C1 all the way up to C10. Okay, so this is C4. Everybody know the name for C5? Pentane, then hexane, then heptane, octane, nonane, and decane. Okay, so memorize these names if you already don't know them. Okay, they're pretty easy to get down under your belt. Okay, so this will serve as the base of our naming of these molecules. Okay. Okay, one of the things that you saw in the previous lecture, okay, something like that would be an example of a straight chain alkane. And then we can start adding branches to them. Okay. One of the things that happens when you add branches is that it tends to lower the boiling point. Okay, we covered boiling points last time a little bit. Okay, what happens is when you have branching, it makes the molecule spherical, and that gives you fewer contact points. Okay, and again, the fewer contact points you have, the easier it is to separate them. Okay, so more branching gives you lower boiling points. Okay, it also gives you lower viscosity. Okay, remember what the definition of viscosity was? If something's very viscous, what does that mean? What's an example of something that has a high viscosity? Syrup. Syrup. If you pour syrup, it pours very slowly. Okay? So a high viscosity means it's pouring slowly. So a lower viscosity is always associated with lower boiling points. Okay, so water would have a lower viscosity than syrup, okay, because it pours a lot faster. Okay. Well, let's get into naming these alkanes. Okay. If, for example, we looked at this 4-carbon alkane, remember that was butane, but we could make an isomer of butane and putting a branch on that carbon there, okay? And one of the ways you could call that would be isobutane, meaning what? That we've created an isomer from butane. Okay? And remember, isomers always have what? The same molecular formula. Okay? If you went on to the next longer molecule, you would have pentane, for example. And if you created an isomer of pentane, you could yank off a carbon and create a branch in there. And create the isomer of pentane, sometimes called isopentane. And you could yank off this carbon and put it here. So there's another 5-carbon isomer. This would be a new isomer. So it's sometimes called neopentane. You know what neo means? New, okay? So a new isomer of that, okay? And so all of these would have the same molecular formula of C5H12. Okay? Are those showing up okay? All right, but we're not going to name molecules with these prefixes. This was just an introduction to show you. You can start like this, but what happens if you get longer and longer chains to start with? What happens? Your number of isomers start going up. So it would start getting ridiculous to start putting new things in front, because you could have jillions of different isomers, and that'd be difficult to memorize all those names. So what we come up with is a new type of naming system. It's called the IUPAC naming system, where scientists several years ago got together and came up with a systematic way of naming. And this systematic way of naming is universal. So the person here, as well as the person in China, would name the molecules the same way. Okay? And it's very, very logical of how to do this. Okay? And students often find this kind of fun. Maybe you will too. Okay? So let's go ahead and start this thing here. Okay, the first thing that we do is we always find what's called the parent chain. The parent chain. Let's look at a molecule to get us started here. Okay, suppose our goal is to name a molecule like that. Okay? So it looks somewhat difficult perhaps, but we're going to make this real easy. Okay? So the first thing we do is we find the parent chain. Write it down. The parent chain is the longest continuous carbon chain from end to end. It is the longest continuous carbon chain from end to end. Okay? Okay? So like if you found maybe a parent chain on your body, it might be what? From your fingers down to your toes. Okay? It wouldn't be maybe from your shoulder to your toes, that'd be shorter. Okay? So it's the longest flow. So where would be the longest chain here? Maybe start here and come down that way. And what you always do is you circle this parent chain. Circle the parent chain. Okay? See what happens when you circle it? What are sticking off of the circles? Branches. Okay? So that helps you identify branches real quickly. Okay? How many carbons are in that parent chain?
7.
Okay, 7. So our parent chain in this case is some kind of heptane. See why you have to memorize those names. Okay? The second thing you do is we number the parent chain. We number the parent chain. Okay? And here we number it from the end closest to the first branch. Okay? So here, if I count from here, 1, 2, 3, first branch. If I come down here, 1, 2, 3, first branch. Well, which end should I start numbering? It doesn't matter, because I have a time. Okay? So since it doesn't matter, maybe I'll just start up here. Okay? If you look, our branches here are CH3s, okay? And the way you do these branches, remember that one carbon molecule is methane. What we do is we drop the A and E, and those are what are called methyl groups. Okay, so we always have our branches ending in YL. Okay? And our methyl groups are on what number carbons? 3 and 5. So I can start writing the name of this thing, 3, 5. That's where my methyls are. I have how many methyls? 2. So I use a di prefix to tell you that there are 2. Okay, so 3,5 dimethyl. And that's all of my branches, so I write my parent chain last for heptane. Okay. See how easy that was? Do we have a question on that? Ask it now. Hopefully that was very easy. Okay? We'll get into other things, different branches, and so on. It gets a little more complicated. Okay? What you also want to be able to do is go backwards. Okay? So what do you mean by that? Well, if I gave you the name 3,5-dimethylheptane, you should be able to draw that structure. Okay? So how would you go about doing that? What do you think the first thing you would draw would be?
The branch.
The parent chain, which is heptane. So I could just draw 7 carbons. Okay? If I don't tell you how to draw it, maybe just use a line bond structure. Pretty easy. And then I see I have 2 methyls on the 3 and the 5 carbons. So if I count 1, 2, 3, 1 methyl, 4, 5, there's the second methyl. End of story. See how easy that is? These 2 molecules are the same. They don't look it, do they? But they are. How do you know if 2 molecules are the same? They will have what? The same? The same? It rhymes with same. Name. They have the same name. Not the same molecular formula. If they have the same molecular formula, they could be isomers. And isomers have different names. So you'll always know if they have the same name. Okay? So if you name molecules and you're not sure if they're the same, just name them. If they come with the same name, end of the game. Okay? Okay. Let's look at this one here. Okay, so draw that. See if you can name that real quick based on the knowledge you have. Okay, so by now you should have the name of the parent chain. What's that? Nonane, 9 carbons. Okay? Now just put your groups in alphabetical order. You're going to have 2 different groups this time. Put the groups in alphabetical order. Your different groups this time are what? Methyl and ethyl. So ethyl will become before methyl. Okay. So you should have circled the parent chain. Then you should have numbered the parent chain. ethyl group on number 5. Then we got methyl groups on 3 and 4. Okay, so look what you're putting in alphabetical order, the E and the M, okay? Not the D. You don't use the prefix in the alphabetical order. Okay, you didn't know that, but you know it now. You use the root name of the branch. Okay? Note too, you're not putting them in order of the numbers. Might be tempted to put 3 before 5. No, it's alphabetical order. Another thing that you're seeing is you separate the number from the branch by a dash or a hyphen. If you have 2 or more numbers, they're separated by a comma. Okay? So make sure you get your commas and your hyphens straight. Okay? And there's no dash or comma before the parent chain. Okay? Yeah.
As far as the parent chain, could it been like maybe a little different, same number as far as 9, but maybe when you got the 4 came over to the right and the end went down? Can't do that?
No.
Oh, but it's not connected.
That's right, it's not connected. It's got to be connected. Yeah.
Could you have started where the 9 was but 1?
Okay, so good question. Could we start 1 up here? No. 1, 2, 3, 4, 5 would have been the first branch. Down here it's 3, so 3 beats 5. That's why we started down there.
Oh, okay.
Okay. Any other questions? Okay, we're just getting warmed up. We'll get into some heavier ones on Monday. Okay, so get into the homework and practice. Okay, next week with the quiz. Okay, you'll see some stuff on degree of unsaturation, some naming, okay, and stuff like that. Okay, we'll see you on Monday. Okay, come up and get your quizzes.